Okay, students. So now let us go to the last part of the chapter, which is really very simple. That is the electrophilic substitution reactions of the haloarenes, students. Okay. So as you can see over here, it's written ESR, electrophilic substitution reactions of the haloarenes. Now, before we proceed this, let me remind you that we have already studied electrophilic substitution reactions in the 11th standard, right? And if you remember some part of it, you need to recall that whenever a halo group is attached to a benzene ring, that is a halogen which is attached to the sp2 hybridized carbon of the benzene ring. Halogen itself is an electron withdrawing group, but when it gets attached to this carbon, it has more number of electrons compared to the sp2 carbon, students. So it will become electron donating and not electron withdrawing. And as the halogen attached to the benzene ring becomes electron donating, it becomes ortho and para directing group, students. Okay, so as you can see the resonating structures, I have taken chlorobenzene. So this electron pair is being donated over here, and then ultimately this electron pair goes outside the ring. Remember फिर क्या करना है, students? You need to do आजू बाजू सामने. Remember? So now the incoming electrophile, which is positive in nature, will go to which position, students? Obviously the ortho and the para positions. Clear? So now whenever a halogen which is attached to benzene ring, that is haloarene, and if it will undergo electrophilic substitution reaction, students, it will always form which compounds? Ortho and para compounds. Clear? Now in that also, students, you need to remember that para will be always a major product and ortho will always be a minor product. Simple reason है, you have already studied this, that para products क्या होते हैं? Crystal lattice में fit होते हैं, and that is why it is a major stable product. And ortho compounds कैसे होते हैं? They are minor products क्योंकि उनका crystal lattice structure एकदम symmetric नहीं है. It is unsymmetric in nature. For simplicity, let us begin with the first reaction. As you can see on the screen, students, I have taken halogenation and I have taken the substrate as chlorobenzene. As chlorobenzene is undergoing chlorination in the presence of FeCl3, right? So as you see, FeCl3 will give you what? Orthodichlorobenzene and paradichlorobenzene. Orthodichlorobenzene and para. And as we have seen, para will be the major product. Similarly, if it will undergo nitration, see over here, chlorobenzene plus concentrated HNO3 and concentrated H2SO4, it will give you orthochloronitrobenzene and parachloronitrobenzene, in which the para will be the major product because of symmetry. And as you see the sulfonation now, students, can you see it very clearly over here? So whenever the chlorobenzene will react with sulfuric acid and SO3, remember, students, the mixture of H2SO4 and SO3 is known as oleum. When this chlorobenzene will react with oleum, it will give you orthochlorosulfonic acid and parachlorosulfonic acid. The names are not written, students, so please keep that in mind. Orthochlorosulfonic acid and parachlorosulfonic acid. Clear? And again the para will be the major product. Clear hai? So please take a screenshot of it very nicely. Apart from this three electrophilic substitution reaction, students, if you remember, we had two more electrophilic substitution reactions. Can you see them on the screen right now, students? It is there on your screen. Can you see that? The first reaction apart from that three are Friedel-Crafts alkylation and the last one Friedel-Crafts acylation. In both of them, there is a Lewis acid which is used, which is anhydrous AlCl3, students. Can you see? Remember anhydrous AlCl3? So again the substrate remains the same, that is the chlorobenzene. I have added methyl chloride in presence of anhydrous AlCl3. क्या हो जाएगा? ये CH3 ortho और para position of the benzene पे substitute होगा. So you get orthochlorotoluene and parachlorotoluene. I have written the IUPAC names, that is 2-chlorotoluene and 4-chlorotoluene. Clear? Then Friedel-Crafts acylation. This is known as acyl group. This CH3COCl basically is the acyl group. Now when anhydrous AlCl3 acts as Lewis acid, will take away this Cl. So what will left? COCH3, and this COCH3 will get attached to the ortho and para position, students, right? So what you will get 2-chloroacetophenone and 4-chloroacetophenone, where the para again will be the major product. Clear? Okay, students, and now comes the polyhalo compounds. This part, students, is not given in the notes. Again, I am repeating, this part, students, is not given in the notes. So I'll highly recommend you all that you take the screenshots. Okay, the only reason this is not given in the notes, student, because these are simple theory, and I'll just read out. You just have to remember few points and few properties of these halo compounds. Okay, students, so let us begin with one of the most simplest polyhalo compounds, which is dichloromethane, the common name of which is methylene chloride. क्लियर. नाउ ये मिथिलिन क्लोराइड स्टूडेंट कहाँ यूज होता है पता है आपको? इट इज अ वेरी गुड सॉल्वेंट बिकॉज ऑफ इट्स, यहाँ पे आपको दिखाई देगा वो पॉइंट, it's a very good solvent because of its low boiling point and low inflammability in pharmaceuticals. It is also used as paint remover and it is also used as propellant in aerosols. Okay, अब उसके बहुत harmful effects होते हैं. Now what are the harmful effects? It causes impairing of hearing and vision. It harms our CNS, which is central nervous system. It causes nausea, numbness in fingers and toes. It with direct skin contact, students, ये बहुत ही burning sensation देता है, because and it also causes the redness rash on the skin, and if it comes direct contact with the eyes, it can burn the cornea, students. So these are the harmful effects of this polyhalo compounds. डोंट वरी, ये आपको याद नहीं रखना है, जस्ट बिकॉज ऑफ द मल्टीपल चॉइस क्वेश्चंस एंड द असर्शन रीजंस बीइंग इंट्रोड्यूस्ड दिस ईयर आपको थोड़ी प्रॉपर्टी ध्यान रखनी होगी. Now comes the next polyhalo compound, students. This is one of the favorite in boards, and which is chloroform, the trichloromethane, CHCl3, students. और उसकी सबसे बड़ी प्रॉपर्टी जो सबसे फेमस है, एंड इट इज वेरी ल्यूक्रेटिव क्वेश्चन इन द बोर्ड एग्जामिनेशन, स्टूडेंट्स, कि क्लोरोफॉर्म को कोई भी कांच की बोतल में डायरेक्टली इन द प्रेजेंस ऑफ सनलाइट स्टोर नहीं किया जाता. CHCl3 is slowly oxidized by air, student, in the presence of light. And when CHCl3 is oxidized in presence of sunlight, student, it forms phosgene. Now this is a very poisonous gas, students, toxic in nature, and that is why they are not stored in glass bottles which are exposed to sunlight. This is one of the important board questions, student. Why chloroform is not stored in glass bottles in presence of sunlight? On the contrary, question ऐसा आता है that chloroform is stored in dark bottles. Why? So dark bottles इसलिए because उसमें light enter नहीं होती, and light enter नहीं होती तो chloroform cannot get oxidized in presence of light, and ultimately it will not form phosgene. Okay. So here, students, the first line itself gives you the question for the give reason. Can you see over here? Chloroform is stored in dark bottles. Why they are stored in dark bottles, students? As we have seen that when it is getting exposed to sunlight, it will get oxidized and it will form a poisonous gas, phosgene, COCl2. So it is stored in dark bottles, which are completely filled up to the brim with 1% ethyl alcohol added to it. Addition of alcohol converts COCl2 into non-poisonous diethyl carbonate. Clear? Now, as you can see, students, there are the number 4, 3 and 2 which are marked star, they are not there in your syllabus now, so don't worry. ठीक है? Now you will definitely directly go to the next set of compounds. What you have, as you see over here, iodoform and carbon tetrachloride, CHI3 and CCl4. Iodoform, students, earlier it was used as an antiseptic, but nowadays it is not used. Now, why iodoform was used as antiseptic? Due to iodine, which was liberated by it. You have heard about tincture of iodine, students. This was the compound which was being liberated. I2, tincture of iodine has been released. but it has been replaced by other compounds due to its offensive smell. Iodoform बहुत ही foul smell देता है students. Okay, then comes carbon tetrachloride. Now carbon tetrachloride बहुत ही important solvent होता है students, and it is a non-polar solvent. Okay, so it is also used in manufacture of refrigerants and propellant of aerosols. It is used in synthesis of freons. Remember freons student? फ्रियॉन्स जो हम लोग क्लोरोफ्लोरोकार्बन्स की यूजेज में आता है, विच आर यूज्ड इन मेकिंग रेफ्रिजरेटर्स, एयर कंडीशनर्स एक्सेट्रा. एंड अंटिल 1960s स्टूडेंट वो फायर एक्सटिंग्विशर में भी काम लगता था, CCl4. डोंट वरी, दैट्स यूजेस इज कमिंग इन द नेक्स्ट स्लाइड, सो डोंट वरी अबाउट दैट. अब ये तो हो गए उसके यूजेस स्टूडेंट्स. हार्मफुल इफेक्ट्स आर देयर इन, एज यू कैन सी. नाउ लिवर कैंसर कॉज होता है स्टूडेंट्स यहाँ से. इट गिव्स यू डिजीनेस, नोजिया, लाइट हेडेक्स, can cause permanent damage to nerve cells, resulting in coma and deaths also. It also causes irritation of eyes on contact. And students, the most important harmful effect of carbon tetrachloride is when it is released in atmosphere, it depletes our ozone layer, due to which UV rays exposure of human beings is increased, which leads to skin cancer, eye diseases, our immune system is affected. So these all things are there. Now I'll give you the uses of this carbon tetrachloride which I discussed right now. Okay, just look at your screen, it's coming, and here we are. Can you see the fourth point? The depletion of ozone layer has been there, and followed by the uses. उसमें last use students बहुत ही important है. This one, carbon tetrachloride till 1960s was being used as a fire extinguisher under the name of pyrene. Okay students, the next one in this category of polyhalocompound students is freons. As you can see on the top, freons. The chlorofluorocarbons are in general known as what? Freons. Okay, they are made up of methane and ethane students. Okay, now ये आपको फ्रियॉन 1,2 और फ्रियॉन 1,3 का आपको important फॉर्मूला याद रखना है. ओके, what is the formula? CCl2F2 is freon 1,2 और CClF3 is freon 1,3. Okay, now what are these freons student? The first line it is written, they are very stable, unreactive, non-toxic, non-corrosive and easily liquefiable gases. अब ये जो फ्रियॉन्स हैं वो आपने ऑलरेडी पढ़ लिया है स्वॉट्स रिएक्शन स्टूडेंट्स, उससे प्रिपेयर होते हैं. कार्बन टेट्राक्लोराइड में अगर SbF3 डाल दूं तो यू गेट SbCl3 प्लस CClF3 विच इज फ्रियॉन 1,3, और CCl4 में ही अगर SbF3 डाल दूं तो अगर एक्सेस अमाउंट ऑफ CCl4 और SbF3 लिया तो हमें फ्रियॉन 1,2 मिलता है. ठीक है, ये फ्रियॉन्स कहाँ यूज होते हैं स्टूडेंट्स? दे आर एयर कंडीशनिंग एरियोसॉल प्रोपेलेंट्स एंड दे आर ऑल्सो यूज फॉर रेफ्रिजरेशन. नाउ इसके हार्मफुल इफेक्ट्स यू ऑलरेडी नो कि ये फ्रियॉन अगर एटमॉस्फेयर में रिलीज होते हैं तो दे आर रिलीज टू स्ट्रेटोस्फेयर वेयर इट इनिशिएट्स फ्री रेडिकल चेन रिएक्शन एंड विच डिस्टर्ब्स द नेचुरल ओजोन. आपका ओजोन फिर ऑक्सीजन के साथ रिएक्ट करके डिप्लीट हो जाता है स्टूडेंट्स. ओके, and the last polyhalocompound students, the most important of all, which is one of the most sorted questions coming in the board, which is DDT students. Okay, now what is this DDT? It is nothing but 2,2 bis 4-chlorophenyl 1,1,1 trichloroethane. Okay, now this is very important students because ये नाम जो आपको IUPAC नेम दिख रहा है वो आता है इन MCQs स्टूडेंट. ओके, सो व्हाट इज DDT's IUPAC नेम? DDT's IUPAC नेम इज 2,2 bis 4-chlorophenyl 1,1,1 trichloroethane. बहुत सिंपल है प्रिपरेशन स्टूडेंट्स. DDT का प्रिपरेशन कुछ ऐसे जाता है. आप ये 2 क्लोरोबेंजीन देख रहे हो यहाँ पे. ओके, एंड दे आर मिक्स्ड विथ क्लोरल. Now what is chloral? CCl3CHO. तो यहाँ जब ये 2 क्लोरोबेंजीन और क्लोरल मिक्स होता है in presence of concentrated H2SO4, you can see very clearly the water molecule being given out. Can you see this? So आपको क्या मिलेगा? CCl3CH और यहाँ पे 2 क्लोरोबेंजीन जुड़ जाएंगे, ठीक है। तो इसके स्ट्रक्चर पे से ही स्टूडेंट्स इसका नाम DDT पढ़ा गया है। कैसे देखते हैं, देखो इधर डाइक्लोरो, डाइफेनाइल, ट्राइक्लोरो इथेन, समझ में आया स्टूडेंट्स? इसकी वजह से इसका नाम DDT, जिसका IUPAC नेम है 2,2 bis 4 क्लोरोफेनाइल 1,1,1 ट्राइक्लोरो इथेन। ओके, अब स्टूडेंट्स इसका यूजेज क्या था? इट्स अ वेरी पावरफुल इंसेक्टिसाइड स्टूडेंट्स। शुगरकेन और फॉडर क्रॉप्स में इंसेक्ट्स और मस्कीटोज को किल करने के लिए काम लगता है। इफ़ यू आर अवेयर, बरसात के मौसम में देर आर गवर्नमेंट ऑफिशियल्स एंड ब्यूरोक्रेट्स विच कम एंड दे गिव द स्मोकी फ्लश टू आवर सोसाइटी। इट्स अ DDT फ्लश ओनली स्टूडेंट्स। इसकी वजह से मलेरिया को बहुत कंट्रोल किया गया है इन पर्टिकुलर पार्ट्स ऑफ द वर्ल्ड, बिकॉज पर्टिकुलरली ये एनाफिलिस फीमेल मस्कीटो जिससे मलेरिया कॉज होता है उसको किल करने में काम लगता है। ओके, नाउ बट इसके साइड इफेक्ट्स भी बहुत हैं स्टूडेंट्स। इट इज़ वेरी टॉक्सिक टूवर्ड्स एक्वेटिक एनिमल्स, स्पेशली फिशेस। इससे हमारा BOD और COD लेवल, आई होप यू अंडरस्टैंड, BOD COD बायोलॉजिकल ऑक्सीजन डिमांड एंड केमिकल ऑक्सीजन डिमांड स्टूडेंट्स बहुत बढ़ जाता है, एंड ड्यू टू विच द रिप्रोडक्टिव सिस्टम ऑफ मरीन एनिमल्स, एक्वेटिक एनिमल्स इज हाईली अफेक्टेड। ओके, तो अब इसके लिए हम इसका यूजेज बहुत ही लिमिट कर देते हैं। ऑल्सो इट इज़ फैट सोल्यूबल स्टूडेंट्स। ये जो DDT होता है, डाइक्लोरो डाइफेनाइल ट्राइक्लोरो इथेन, इज फैट सोल्यूबल एंड अ वेरी स्टेबल कंपाउंड, सो इट इज़ नॉट मेटाबोलाइज्ड बाय एनिमल्स एंड ह्यूमंस। ओके, तो इसका कंजम्पशन और उसका लेवल अगर ह्यूमन बॉडी में इंक्रीज होता गया तो इट हैज़ अ टॉक्सिक इफेक्ट। Okay, so the uses and the side effects students has been mentioned over here, so please take a screenshot. Okay, and as I said, this is not a part of your notes, so please note it down. Okay, and yeah, with this we come and conclude this chapter. Okay.